Lecture 5. Unordered sampling without replacement. Subpopulations. In the previous lecture, you learned how to count ordered subpopulations. In this lecture, you will learn how to count unordered subpopulations. To begin with, let us discuss the following problem. Problem 1. How many ways are to pick 2 cards out of 4 cards without replacement if we disregard the order of picked cards? Well, here's the solution. Say I have 4 cards, ace, king, queen and jack. If I shuffle the cards and then choose 2 random cards, how many different outcomes can I get? To begin with, let's count the number of possible chosen pairs of cards, keeping in mind what card was chosen first and what card was chosen second. Then, for the first card, there are 4 choices. Indeed, I can choose ace, jack, king or queen. And then, after the first card has been pulled out, there are 3 choices left for the second card. In other words, in total, there are 4 times 3, which is 12 choices. Let's actually write down all possible outcomes. When we pull ace and king, ace and queen, ace and jack, king and ace, and so on. There are in total 12 different pairs. Problem 1 actually asks us to count somewhat different outcomes. We have counted ordered outcomes where the order of pulling out cards matters. In problem 1, we are asked to disregard the order. In other words, in our list, for example, the pair ace and the pair king and ace correspond to the same outcome. Indeed, the pair ace and king means that first we pulled out ace and then we pulled out king. The pair king and ace means that we first pulled out king and then we pulled out ace. In both cases, we ended up with the same unordered pair of cards, ace and king. Similarly, every other outcome in our list appears twice. To summarize, overall, in the list of possible ordered outcomes, there are 12 pairs. However, when we disregard the order, we have to take into account that we counted each outcome twice. Thus, the number of outcomes is actually 4 times 3 divided by 2, which is 6. End of solution. Now let us move to the general problem. Problem 2. How many ways are to pick m balls out of n colored balls if we disregard the order of picked balls? Solution. There are n sub m ways to subsequently choose m balls out of n balls. Indeed, if we care about the order of drawn balls, then there are n choices for the first ball, then there are n minus 1 choices for the second ball, and so on. In total, there are n sub m ways to subsequently choose m balls out of n balls. On the other hand, 2 choices of m balls are the same if they differ only in the order. There are n factorial ways to order a set of m objects. Thus, there are n sub m divided by n factorial ways to choose m balls out of n balls. Notation. The number n sub m divided by m factorial is denoted by n choose m. In other words, the number n choose m is the quotient of n times n minus 1 times and so on times n minus m plus 1 divided by m times m minus 1 times and so on times 1. Let us now multiply the numerator and the denominator of this fraction by n minus m factorial. Then the numerator, which was n times n minus 1 times and so on times n minus m plus 1, is now multiplied by n minus m plus times n minus m minus 1 times and so on times 1, which is now n factorial. And the denominator is now multiplied by n minus m factorial. In total, we have n factorial in the numerator and m factorial times n minus m factorial in the denominator. This is a very well-known formula for the number n choose m. By the way, the number n choose m is also known as a binomial coefficient. We will use the convention that n choose 0 is 1. And of course, 0 factorial is 1.